Good day, Engineer Saldo Tugate. Together with my group mates, we are here to discuss our laboratory experiment for the flow-through fittings. The objectives and aim of this experiment is to determine the report equivalent length of the fittings and compare with it from each other types, such as elbow, T-line flow, T-branch flow, half-open globe valve, fully open globe valve, gate valve, swing check valve.
The experiment was performed to investigate and determine the effect of special pipe components and fittings to the pressure drop encountered in a hydraulically smooth pipe under laminar and turbulent flow situations. With this experiment, we were able to quantitatively report and compare the equivalent lengths of the fittings. The procedure was performed simultaneously with given parameters such as the fittings used were elbow, T-line flow, T-branch flow, half-open globe valve, fully open globe valve, gate valve, swing check valve, and the diameters used were that of 0.25, 0.5, 1.0, and 1.5 inches in an HG manometer. By accomplishing this experiment, we were able to determine that for both kerosene and water, the use of a fully open globe valve required longer fittings of about 1.5 meters to achieve similar performance with the other fittings. For all diameter tested more prominently in smaller diameter fittings such as 0.25 and 0.5 meter. The majority of the fittings can perform similarly with the length of less than 0.5 meter.
Introduction. One of the most common problems in fluid mechanics is the estimation of pressure loss. Calculating pressure losses is necessary for determining the appropriate size pump. Knowledge of the magnitude of frictional losses is of great importance because it determines the power requirements of the pump, forcing the fluid through the pipe. For example, in refining and petrochemical industries, these losses have to be calculated accurately to determine where booster pumps have to be placed when pumping crude oil or other fluids in pipes to distances thousands of kilometers away. Pipe losses in a piping system result from a number of system characteristics, which include, among others, an example, pipe friction, changes in direction of flow, obstructions in flow path, and sudden or gradual changes in the cross-section and shape of flow path.
These are the materials that we used in flow-through fitting experiment. Water and kerosene as the process fluids and mercury as manometric fluid. These are the procedures on how we conduct the flow-through fitting experiment. First, set the value of nominal diameter of the pipe and select the type of fittings. Second, set the process fluid to water and the manometric fluid to mercury. Third, start the pump to run the simulator. Fourth, set the value of the flow rate ratometer with increasing value until it reaches the maximum flow rate. Record the H1 and H2 of the manometric fluid. Sixth, repeat the process at the different nominal diameter 0.25, 0.50, 1, and 1.50, and different type of fittings, elbow, T-line flow, T-branch flow, half-open globe valve, fully open globe valve, gate valve, and swing check valve.
For the experimental setup, the virtual laboratory features all required fittings and different pipe diameters. The laboratory apparatus is consisted of an inlet tank and pipes mounted on a stand that are connected to the inlet tank. Each pipe is provided a suitable distance apart. A regulating valve is provided at the downstream side on each pipe to regulate the flow. A U-tube manometer containing mercury is connected between two pressure tappings. This is the virtual laboratory from NITK Chemical that we use in order to execute the experiment. As you can see, there are several parts of this equipment on the simulation. First, the pump, bypass valve, main valve, float, rotameter, tube manometer, and all the fittings given in the pipings.
In order to do the objective of this experiment, we use JMP, John's Macintosh project, to do the t-test. Using the software, we were able to see the significant difference of all pipe fittings, based on the different diameters and process fluid that we are using. We use all raw data that we have gathered in order to get the comparison of the all fittings with at least 2 proofs. As you can see in this particular diameter of 0.25 inch for all water types of fittings, the graph are not totally flat because of the difference of the values per fittings. We use also the mean and standard deviations in order to observe the similarity of the values in different kinds of fittings. In this particular diameter, as you can see, there are no same values of fittings in the table. This is the other findings in different diameter for water and for kerosene. As you can observe, there are more some points in the kerosene test have similarities between the given fittings. Elbow and gate valve fittings are observed to perform insignificantly different from each other, while other fittings observed to require longer fittings than the elbow and gate valve. Fully opened globe valve observed to be the most significantly different from the rest of the fittings, which requires longer, that 1 meter length, compared to the rest which requires less than 1 meter length fittings. Here are some raw data that we have gathered in order to do the objective of this experiment. For our conclusion, applicable for both kerosene and water, the use of a fully opened globe valve required longer fittings of about 1.5 meters to achieve similar performance with the other fittings for all. The diameter tested more prominently in smaller diameter fittings such as 0.25 and 0.50 meters. Majority of the fittings can perform similarly with a length of less than 0.5 meters.
Next, we need to know the potential hazards that we encounter if we utilize this experiment in the real laboratory. First, the exposure to mercury. As we know, mercury exists in various forms such as elemental, inorganic, and inorganic. These forms of mercury differ in the degree of toxicity and their effects on the nervous, digestive, and immune system, and on lungs, kidney, skin, and eyes. Next, for pump. The risk from a pump in the pipe blowing and causing injury to person can happen. Appropriate control measures include well-maintained, high-pressure clamps and securely anchored safety chain fitted to the instrumentation cap are needed. Next, for waste disposal. For proper disposal of mercury, mercury is considered as hazardous waste. When products containing mercury are placed in the trash, the mercury doesn't disappear. It finds its way into the environment. That's why mercury-containing products cannot be disposed of with regular trash or poured down the drain. Mercury products and compounds must be recycled or managed as hazardous waste. This is the steps for proper disposal of mercury. First, put on gloves or clothing, all shoes, and remove jewelry. Second, transfer mercury with an eyedropper. Next, seal and label bags or containers that contain mercury waste. And finally, find a location to dispose of mercury waste. Thank you for listening.